Okay, everyone, let's get started. Thanks so much for joining us today. I'm Loretta Jones, VP of Growth at Acceldata, and appreciate you giving us your time today to learn more about our Data Observability Cloud. With me, I have Tristan Spalding, who is the head of product at Acceldata. So he'll go through a few slides just to give you an overview of the product, an overview of the solution, what we're trying, and the problem that we're trying to solve, and then we'll go right into a demo. We also have left time for questions, so if you do have any questions, please put them in the Q&A or in the chat, and we'll go over those questions at the end of the demo. So Tristan, why don't you take it away?
Great. So thanks so much, Loretta, and thanks everyone for joining today. As Loretta mentioned, I get to work all across Acceldata with our great engineers, our great support team, great marketing team, great sellers, things like that. And today, I just wanted to give an introduction to a little bit of who we are as a company and very quickly get into the Data Observability Cloud and what exactly we mean by that. And so we'll start off with a little bit of an overview on where this sits, kind of in the modern data architecture, the modern data landscape. And we'll pretty quickly jump over into an actual tour through the product. And again, as Loretta said, happy to take questions. And we'll wrap up basically by showing how you can get hands-on with the product, either at a workshop that we'll be setting up and running, or actually directly in our cloud service today, signing up for a free trial and getting hands-on with your data there. So without further ado, let me start by sort of framing where we are. So I think for a lot of companies, there's a vision which is partly realized, but certainly a major initiative of using data products, reframing how we think about data from sort of a more of a cost center and something that we're always chasing to something that's really driving value, whether that's data products that are reused inside an organization or increasingly data products that are actually used to drive revenue, either directly by using in data exchanges, data marketplaces, or indirectly by offering analytics or powering machine learning models on top of that. So I think there's a lot of grand vision, a lot of excitement as we look at how we see these data products going off and what we see them doing. For those of us, sort of more on the inside and the data teams, this is a little more what the perspective looks like. It's a little bit, a little bit blurry, a little bit cloudy, and trying to figure out how we're going to navigate all of this at high speed without visibility is hard to imagine. And so, really data observability, there's a reason that started to move to the forefront and in terms of some of the biggest priorities for many organizations. And so for us, we're very aligned with Gartner's definition here. I know everyone has their own definition. We sort of go with Gartner's around, there's really 4 aspects around this. You need to data is a complicated thing. You can't just look at one side. You need to understand what's upstream, what's downstream, who's using it, what the underlying compute layers are, which are actually consuming costs and driving performance. And so Gartner has a great report kind of articulating this. And you'll see as we go through this, how the Acceldata product really hits all of these points together. So Data Observability Cloud, the product that we're offering now, this is basically what we try to do. And I'll clarify one question in advance here, just as we go through. But essentially, what this is going to let you do is get comprehensive insight into your whole data stack in order to improve data efficiency, pipeline reliability, compute performance, and basically spending as well. So my clarification on this is that while what we'll talk about a lot is around cloud, around cloud services, this is actually available also not only as a managed service, but as software that can be installed in your VPC. And in fact, that's one of the largest deployment scenarios that we observe here. So what we're going to do, why now? What's happening now that requires this? So I think it is around these data platforms like Snowflake and Databricks, Confluent. There's many more that are coming out around here and having tremendous success. And they're having success because they offer incredible benefits. I mean, I think for people that have been using data for a long time, you understand how easy it is to get started with these, how powerful they are. The ability to scale up instantly by selecting a different warehouse size from a drop down in a beautiful graphical user interface. It's amazing that you can get this acceleration. It's also amazing that this gets upgraded for you. So those of you who've done, upgraded your traditional databases, that's a huge process. Instead, with Snowflake, with Databricks, with these cloud data platforms, they're getting updated all the time, transparently to you, and new features are available. So I think there's some tremendous benefits. These also have a flip side, and It's just something that, with the benefits comes some of the costs and some of the risks. So I think what you find, it's so easy to get started that you don't need to take a 90-minute or a full week training course to understand how to use Snowflake. Databricks maybe does have a little bit of a learning curve as well, but you're up and running. You're doing that learning curve, often in the platform itself, and that has a lot of good things. It also potentially leads to some, mistakes, and those mistakes, are not free necessarily. I think the other aspect, that's interesting with this, right? They're upgrading all the time. So, and those of you who use this, depending on where you sit in the organization, whether you're a data engineer, a data platform owner, even a data analyst, you may or may not be reading the details of every release note from every cloud data platform, but they are putting out great things every month. I always encourage people, customers to look outside of it. Look at this. Look what's come out in October, September from these companies. It's great, but did you update your workloads and your own configurations to take advantage of that? Is often a different question. So there's some lags. There's a little bit of free lunch here that people can do. I think the last bit with this that people may have experienced, depending on where you are in your adoption, is around how predictable and really how level is this growth. So in many cases, you can be doing everything right. You can be putting in good practices, and suddenly there's a data problem. There's a query that's particularly bad. There's a table that didn't have a timeout on it, and you realize not right away, but a few weeks down the line, hey, there's a huge mistake here. Basically, like, we've been burned on this. We've burned a bunch of credits. This can never happen again. And this is the type of thing that gets into sort of the CFO chain type of thing, which is not necessarily where we as data people want to start off. And so all of these aspects, what we're trying to offer here essentially with data observability from Acceldata is helping you make the most of these leading cloud data platforms, take advantage of all of these key traits that aren't available with traditional platforms, but really avoid these risks. So get the best of both worlds here. So where does this sit? So I think one of the things that we have experience with just at our company, a long history of people working in the data world, is that it's not always simple. There are companies that have sort of been born in the cloud, and their services, even then, are a little bit spread out across different vendors, different platforms. But for enterprises that really have decades of data investments, it's not simple, and things don't necessarily originate in Databricks or originate in Snowflake. They go through a lot of steps. And so the Acceldata perspective on data observability is that you really need to push a lot of the analysis left. So there's, people use the term shift left. Well, for us, shift left means push all of the analysis we're going to do as far back as we can. Look at the files, look at the streams, even look at the applications basically that are feeding us upstream. And the more that you can get visibility here and gate things here and apply efficiency here, the more that you avoid spending time and credits basically on firefighting and on queries down at this end of the spectrum. And so you'll see how some of our technology choices, we've chosen a quite different architecture under the covers that allows this, and you'll see some of the benefits as we go through. But broadly, we look at kind of this window of not just these platforms, not just the warehouse, but actually the data upstream, and even these systems, whether it's Airflow or Prefect or whatever the system might be, even for data science, for ML flow or something like that. These systems that are orchestrating and reading and writing data and transforming data as it goes actually between each of these steps. So when we look at what this is, and getting a little more concrete around what are these capabilities and why do they matter, we basically break this down into 4 elements that we think are quite important. So this data reliability shifting left that we just spoke about, the multi-layer insights, the fact that something is an operational control center, something you're going to react to today, and not necessarily retrospectively look back every quarter or every month and say, hey, we should have done better. These are the things we could have done better. And then finally, the idea of complete data coverage. So not needing to make such severe compromises when it comes to understanding and protecting essentially the reliability of data based on platform, based on cost, based on the complexity of the type of rule you're trying to express. So to dig a little deeper on this here, we talked about files and streams. This is quite important, right? And so basically, this is this is powered by, one of the choices we made here is to use Spark actually and deploy our managed Spark or use your Databricks cluster in order to actually run even very complicated, even multi-data source, cross data source, data reliability checks. And I'll show you in the product a little bit what those look like. But being able to express this up here is a significant difference when you start thinking about what data pipelines look, how long they take, and the cost they incur. So what we think this does, of course, this is a sort of data engineer oriented company, things like that. So we've got our little Pareto frontier here of, we think with our technology, with our Spark-based data observability, you're able to do more basically in a given amount of time, given budget, and not make those choices. And we've seen some great success with immense data companies that are making they make their business off data, who've been able to dramatically speed up and increase the coverage that they have while reducing cost by using this rather than let's say alternative data reliability, data quality tools. So multi-layer insights. So what this is trying to say here as well is that when you're analyzing data, when you're looking at these pipelines, so as a data engineer, as a data platform owner, many of you may have been in a situation where you see that something is going wrong, right? So we notice, we get an alert, we see that flag. The question is why? What caused that? And how quickly can we go from noticing this incident to actually resolving this incident? And so what you'll find is often this actually requires jumping between areas that can sort of bridge skill sets that people, like one person isn't necessarily an expert, both in Databricks and in Spark and in the actual data sets that are going through. And so what we're able to do is do things like, hey, this data is late, this data is delayed. Was that because the query was queued that was on? And was the query queued because the Snowflake warehouse was too small? And was the Snowflake warehouse too small because this group was forecasted to go over their budget, so we constrained the warehouse so it went down? These are, especially in the cloud data platform world, where you may have decentralized teams operating these tools and their own accounts a little bit autonomously, being able to see this context and move between layers becomes quite essential. I'll highlight another one for you. So one of the big differences with cloud data platforms is that your queries on bad data, they're not just producing bad results, they're actually burning compute cycles as well. So it's not just time that you're going back and fixing this, and the trust that you erode, those are all there. They've always been there, but it's actually, queries, inserts of bad data, like these cost at least as much as they do with good data. So this is another aspect where if you're looking at, I've got this bill, I've got this trend line that I don't feel great about, I need to prepare a budget, where can I, sort of trim the fat, or where can I align things so that I'm still achieving the success that these platforms can deliver, I'm still achieving these transformative goals, but I'm staying on a reasonable budget curve. This is one of the things that's not obvious unless you are looking at multiple layers. So we see this as a big thing as well. The last bit, so data pipelines. So the data pipeline concept is one of the most exciting ones that we've seen recently, and it continues to explode in terms of the ways that people are expressing it. It's like whether people are expressing them in DBT, whether they're writing them in Python, they're orchestrating with Airflow, or one of the many others, or whether it's these traditional, workhorse drag and drop ETL tools. Pipelines are all over the place, and they're quite complicated, right? Because in many cases, they're bringing data from different systems, combining them. They're running at particular times. They need to deliver data at certain times. And so one of the things that we really aim at is orienting our platform around pipelines and instrumenting those pipelines, pulling all the information back into our central hub, and really giving the notifications and the insights and alerts you need in order to really diagnose where are the problems here, let's fix it. Let's not say, hey, this is someone else's problem, route it to them. This is someone else's problem, route it to them. But actually say, let's go in, we have the tools to fix this, and we understand the context of what we're doing enough to prioritize. The next bit, so we go into this. So for an operational command center, now we've talked about, we're trying to find the issue, we're trying to fix it. So what you'll know if you've dabbled with each of these, and as we go into the demo, you'll see this as well. These are quite different systems. So even taking Snowflake and Databricks as kind of a couple of the big sort of big giants, in this area, these are significantly different platforms. The functionality is to some extent, you can see these starting to overlap more and more, but the concepts, the terminology, the details are quite different between them. And so what we find is it's often rare for a given data team in an organization, even a very large organization, to really have deep expertise in both. And so we sort of take that as part of our mission, our reason for existence as a company, is to really stay on top of all of this. So read the release notes, hire experts, train experts, partner deeply with each of these providers in order to know what's coming, be prepared for it, incorporate it really before it comes out. So our hope is that, even if you're very experienced with Snowflake or very experienced with Databricks, with the Acceldata Data Observability Cloud, you're going to get augmented with some of the time that we spend trying to comb through all of this and aggregate data and synthesize it into a product for you. We'll bring these into one tool. Many times you'll get nice views in one area, nice views in other areas, but you won't have the ability to pull them together. And why does that matter? Well, one, because things are entangled. Data pipelines might start by, they wouldn't start, but they might have a phase where they put data in S3. It's then processed by Databricks, and then that's loaded into Snowflake. So when you think about how are we going to optimize this, how are we even going to measure the impact and the cost of this, well, having these in one view is quite essential. The other one that may be on people's mind, given where we are on the calendar, is budgeting. So understanding how these systems are being used and really what their growth rate is among these different groups is a little bit hard to reconcile unless you're able to pull into one view. And this is something that we offer with Acceldata here. So the last bit here really comes into data reliability. So we think, as I mentioned, we think this is an essential piece, often overlooked piece when it comes to efficiency with cloud data platform investments. So one of the challenges with data reliability is always, how do you get going quickly? Like, how can you cover this data? Which systems do you support? How much work do I need to do to get started? And then can this even capture what I needed to capture? So for example, there are some simple checks that make sense to do, right? Like check if data is late, check there's more or less data than expected, check if values are within a certain range, things like that. There's some simple rules, and these are things that Acceldata automates, a lot of other tools automate as well. That's sort of the basic thing that you point at your data sources and get an initial measure. But in many cases, especially for organizations that have been monetizing their data or really building data products, maybe even in advance of the term data product becoming popular, there's a lot of custom rules. Like, it's not enough to just sort of point the machine at and say, figure it out and tell me something interesting. That's a good part, but the extra part comes after that. And then we work with organizations that have hundreds and hundreds of rules that they've expressed in many languages, some proprietary, some not, over time. And it's really essential that they're able to author and manage and apply these at scale with all of the sort of bells and whistles and fanciness around segmentation, alerting, reporting, all of these things that you expect from sort of a modern tool. And so our claim, and our one of our guiding lights at Acceldata is really to take this premise, this span of simple checks and tables, and broaden it all the way to complex, user-defined, cross-table, cross-file, cross-stream connections between these. And so what you'll see as we go through the product, you'll see kind of basic checks automated. You'll see medium checks like data drift and anomaly detection that might be more appropriate for data science workloads. You'll see those turn into one-click operations to add. And you'll also see, custom UDFs that we're writing and applying those and segmenting those across the board. So we think it's essential. Great to have data quality, but unless you're easily able to apply it and affordably apply it at scale to everything, it doesn't do a lot of good to have those capabilities. So that's where we really look at, our 4 principles, just to sum up. And hopefully that gives a little bit of an orientation to some of the key features. And with just a little more summary and intro, I will then jump in and give everyone just an initial sort of experience and tour of what the product looks like. So just a couple of things to keep an eye out for, depending on your orientation and where your focus is as we look into Snowflake and Databricks. So you'll see, keep an eye out for the specific alerts that we have, keep an eye out for the guardrails, the automatic, sort of the resource controls that you have on here, and keep an eye out for how we look at the reliability of the tables alongside the cost. Similarly for Databricks, Databricks is a very deep platform, as many people have experienced, and it's getting deeper and it's also getting broader. So what we'll show you with this is really how we can consolidate a lot of this richness and really technological power into something that's hopefully, what we aim for is a very coherent, cohesive experience on finding the insights and the information you need from all the information that's really emitted at the workflow level, at the executor level, and everywhere sort of up to the up to the entire account level and workspace level. So we'll keep an eye out for that. All right, so with that, let me jump over, and unless Loretta, you think we should pause for questions, or we can wait until later.
Joe, why don't you go into the demo, and then we'll take some questions after. Thanks.
Great, sounds good. All right, so let me jump over to the demo here. This is pulling up our cloud instance here, so our cloud control plane. And what I'll do is basically sort of take you through a little bit of a tour of the different capabilities here and show off how this is going to help us get some mastery over the our key cloud data platforms. Okay. So where we're starting off at the top level is really a view of both the data sources that we're looking at, these data platforms, as well as the data assets underneath it. So we're seeing what our costs are for these over time. What we're going to do quite shortly is dig into these, kind of diagnose where are there efficiencies, where are there inefficiencies, where are there our issues we're seeing, what is this going to cost us next year, things like that. But underneath this, just to show you as well, this is actually looking at the data assets as well. So each of these platforms across Snowflake, across Databricks, you can see here, these have hundreds of tables, thousands of columns, and of course it could be many, many more. And so what we're able to do, this is where this multi-level piece comes in, is we're able to connect these two. And so if we're spending a lot of money on something that we're either getting exceptionally poor data reliability on, or we're not even testing for data reliability, we're not even executing any checks on if this data is reliable, this would be kind of a key action I might want to take if I wanted to understand, how I can really get results from my data platform, my Snowflake or my Databricks spend, without excessive, really exceeding any budgets that I might have set up. Okay, so the first thing we're going to do is kind of walk through here and take a look at this Databricks instance, and we'll then sort of go through Snowflake, and then we'll see a little bit more about the data sets and the data pipelines underneath all of this. So across here, what we're basically going to see is a breakdown of some of the usage here. So I'll just bring this back to what's a good time period, maybe the last 7 days, let's say the last 14 days. Basically see a little bit around the cost trends. So where actually, are we spending resources on this, and by whom, and how efficient is that? So from the top level, what are we spending on Databricks versus what are we spending on the underlying compute? In this case, this is AWS, it could also be Azure. What are we spending on the underlying compute? And then breaking this down, not only into the type of resource that we're using, but also into the individual job. So let's reload some of these. Let's go to the last slide. So basically then now into the core usage and then the efficiency as well. So you can see we're capturing some of these assets, and then we're also looking at basically the efficiency of this. So this is one of the challenges with Databricks often, is that it's incredibly powerful. There's a ton of scale. It's also very hard for new users to really understand and optimize the resources. So which size instance should we be using so that we're not leaving cores idle throughout our job? And you'll see a lot more as we go through this, but you'll see lots of things. I think the other classic one is using sort of interactive clusters versus all-purpose clusters. There's a lot of knobs you can tune, and tuning them well can make a big difference. So with this, we're basically flagging, a few people that maybe are running, some applications that are not that effective. So we'll look at Umesh here. So with Umesh, I'm going to come back and look at, a little closer at these applications, and sort of see across the board, what are they using in aggregate. We can filter this in. I'm going to click on Umesh here and actually get a list of these applications themselves. So you can see hopefully how we're going, pretty quickly between a high level bit of information around where are we spending money, where are we spending resources, in actually to logs, and then even into applications. Let me apply this back for him. And so what we'll do is, instead of these, many times these can get scattered, they can get lost. Acceldata is pulling them all in and making them all, doing some analysis right away, but also making them available for deeper inspection. So with this, I'll actually dig in to this application, or now what we call a workflow. And we're going to get a ton of metrics on this, like more metrics than like a casual user would probably pull out together. But really the set of metrics that you're going to need in aggregate in order to really solve the problems on this quickly and introduce some efficiency here. So just to give you a little bit of a sense of what we're capturing, we get these aggregate informations on this, but we can go down really to, to the second of the execution within each of these. So we're able to correlate where are you taking, how much are you shuffling? Like we'll go through here, you'll see some information on how skewed the tasks are, which in this case actually is quite significant. And these are factors that can really introduce inefficiencies in how long this is taking, and that by really altering this and setting up the partitioning strategy to match your data as it's genuinely coming in, you'll see a lot of improvements in terms of your efficiency. We'll bring in a timeline as well. Where are you spending time? Well, in this case, we're spending much of the time in the driver. So that might be okay. That might not be what we want to do. And this gives a little bit of the diagnostics into how we might be able to do that. Okay, so again, these sort of correlated views, debugging information, so that if I'm given a job, I want to understand why is this slower than it used to be. Now I'm able to actually pull in and do that, discuss that, and resolve it as we go through. You'll also see some information on runs that we can compare here. So many times these applications, as we'll see actually from some of our pipelines in a few minutes, these can be run every day, multiple times a day. But in many cases, you're expecting some amount of stability and some amount of recurring work to happen. This will automatically flag for you what's different about this versus the previous run, and really help again with sort of the diagnostics on, is this behaving as expected, or is there something unusual that we need to investigate here? Okay, so this gives you hopefully a little bit of a sense of the depth that we go into on the Databricks side, and some of the capabilities that allow you to really wield this platform really effectively. Snowflake is more interesting, and this is one of the nuances across these platforms. Snowflake itself does not necessarily offer the same details that Databricks does, for example. So it doesn't, Databricks, Snowflake doesn't actually necessarily publish the exact instance sizes that you're using, let alone sort of the memory consumption within each of these all the time. So a lot of the details that you need for Databricks that we've sort of built up our expertise on and built into the platform now, it's a little bit different for Snowflake. And so what our Snowflake experts have done here is really curate a little bit of a different experience. So this shows you, this will show you and break down basically at the service level, at the warehouse level, at the query level, even user level, all of these dimensions, what things are costing you and where there are inefficiencies. So as we go across, we'll just get a sense, even at the most basic level, okay, how is this trending over time? Okay, up and to the right, I think that's typical. What's sometimes interesting though is when you start seeing these spike. If you start seeing storage spike, so storage usually is not the headline item, but it can actually in aggregate accumulate some significant costs as well. So it's worth breaking these aspects down. What you also see, commonly as well is basically, where this is trending. So based on historical usage, where do we sort of see this going, and how does that relate to the capacity that you purchased up front? So in many cases with Snowflake, people are so happy with it. It's so easy to use. They start using it a lot, and then it's maybe not as trued up with what was purchased as people would like, and we end up with surprises. In this case, you're not going to get surprises, right? You're not going to get surprises because it's telling you what's being cost here, and because you're basically consistently getting alerts across this on what these where things are failing, where these credits are being consumed faster, where queries are queued. So let me just take a second here to flag this a little bit and just show a little bit of what comes out of the box on this, as well as what you can compose yourself as you need to extend this, right? So basically, automatically, as soon as you are connected to your Snowflake cluster and we get some basic information on what you're using, we initialize these alerts. And basically, you'll identify where you'd like this to go, Slack, email, your webhooks, embed them into other tools, all sorts of choices. And you'll start getting alerts on these when you exceed where you should be. And that could be things that, hey, queries are queued, maybe we need to increase the size of the warehouse, or we're spending too much, maybe we need to throttle this down to things like, hey, we have a new user that signed up that has permissions that maybe they shouldn't have, or maybe has a default warehouse size that's an extra large, and maybe it should be at small. So all of this is really in the service of helping you avoid getting into a situation where you wake up one day, things have been going great, no news is good news. We're demonstrating some great impact with applications building on Snowflake, and realizing that maybe you're on path to be way over, the credits you purchased in advance. By the way, there's a similar, kind of set of resources here for Databricks as well. Okay, the other sort of cross piece we'll look at, and then we'll talk about what some of the levers we can use to really reduce this. The other part that's important to understand is basically a chargeback concept or a showback concept. So what we've done here is essentially set up cost centers, which can be attributed either to Databricks resources or to Snowflake resources or to both. And by linking up these cost centers, we're able to see, basically where is the usage, right? Which groups in our organization are consuming resources, and hopefully they're getting some benefit out of it, but that's something we can interrogate. But which groups are consuming resources? How is that trending? Is there anything unusual we've seen in terms of the adoption? And so I think this becomes quite helpful in trying to understand, what do we need to forecast? What do we negotiate sort of for the next year or whatever the time period is in order to, sort of stay on plan here. So for example, and it's not always enough just to come in and look at sort of the headline like that, because if these platforms are so powerful that they grow so quickly that you end up with a scenario like this where, someone starts using Databricks in September, suddenly it's $4,000 a month, in the next month, and potentially that's only going to grow as things scale. So this, I think, becomes a useful tool to kind of flag where there might be some issues worth investigating. Now I'll talk about a few of the things you can do to actually drive this down a little bit without sacrificing any functionality, and in fact, with accelerating the success on these platforms. So the first thing you can do on this front, again, quite different from the Databricks side, or just a different angle that we found effective here, is around accounts and users. So here we're basically auditing, tracking all the users that we have here, understanding what their roles are, understanding what their certain key traits like their default warehouse size, which one that actually is. Do they have multi-pack? Like, are they actually properly set up? Things like that. Because I think one of the most common aspects, and certainly Acceldata, I will admit, was guilty of this in our initial adoption of Snowflake, is sharing passwords, sharing accounts, reusing things like that, really not having any insight into that. And so one of the easiest things you can do, to kind of flag, at least understand where you are, is flagging, who's actually using this platform? Are they set up right? And do they have the roles they should have, or do they have excessive roles? I'd say the next tier on this is that what you'll often find is people, whether experienced users or not, will often spin up new resources, like new warehouses, for example. And these may or may not have the controls that you really should have, and they may not be as tight as they should be. So whether it's things haven't been suspended, warehouses aren't set up for auto suspend, they're a bit too lenient with that, or whether there isn't a resource monitor, there isn't a statement timeout, or it's too high, there's no measure on these things. Like, this will often happen, and this is how things sometimes slip between the cracks, even in really tightly managed organizations, when that management isn't automated, because it just takes one warehouse and one query to really create some of these horror stories that we've heard, where unbelievable amounts of money get spent, and no one ends up happy with that. It's just sort of something that's slipped through the cracks a little bit. So this will flag it. You'll also get an alert, but this is always a place where we go in and say, and basically audit, okay, does this have a resource monitor? Does this have a statement timeout that it should have? And if not, it's something we can easily apply. The other aspect I'll highlight is really, there's two sides of it. One is things that are not being used. So I think there's a general, even if storage is not your most obvious headline item, in many cases, like there can be a silent sort of harm done here with or not a harm, but like a silent cost through auto clustering and even just keeping this data around. So we'll flag users that aren't doing anything, warehouses that aren't doing anything, tables that aren't doing anything, views that aren't doing anything, especially, by the way, with some of the enhancements around query acceleration service and materialized views. This management of views also becomes an interesting sort of constant question that people need to balance in order to really use this platform as effectively as they can. Okay, the last bit, that's kind of another free lunch type of thing, is flagging people that are using drivers that are out of date. So it's not the most glamorous thing, but it is the type of thing that adds up. So this driver is actually quite old by this point. I think the latest is something like 3.13 something. So this is actually missing quite a few updates that security fixes, functionality, new features, as well as performance improvements. So this is another kind of easy thing to do but not having it be automated means people don't always pick it up. It's not top on your list. Well, in this case, we're providing a list for you, so it's much easier to do. So let's dig in now into a couple of the bigger, biggest drivers really of where there can be issues. So this is really looking at, I'll talk about primarily about two things today. Let's do three. So queries, warehouses, and then tables. So for queries, this is what you're running, right? And we do a lot of breaking down of this across a number of dimensions. So understanding where things are spending time, where there's execution time, where things are taking a long time to compile, and so forth. I think the more interesting part of this, and the most interesting parts of this, ends up being around queries that are have certain bad traits to them. So they're either running for a long time, they are doing scans across the entire table, they're spilling to disk. These are all issues, and this is all interactive. So let me get rid of these extra smalls. Like I don't think we care too much about the extra smalls. So let's filter these out and apply that, and get to some queries that are spending a little more resources here. So if we do this, we're now let's get rid of the nulls too. We're now going to see a little more in terms of some significant queries that are running. And what this does is give us the opportunity to basically identify which are running well, which could run better, and basically where are we spending time, and what are we getting from that. On the warehouse front, so the warehouses are really primarily what's going to be driving cost in many cases. What we're flagging here with this warehouse load view is basically where there's less load than the warehouse really needs, right? So if you've got something and we've got this default warehouse, so really 60% of the time, this warehouse is not really at capacity. It's over provisioned in a sense. So this is something where, given that larger warehouses are more expensive than smaller warehouses, it's something where you can really win by reducing, at least considering reducing the size of this and seeing what the results are. Similar here, we're running these. There's not a lot of load for much of the time here, and so potentially this could be resized. You'll also see, in some cases, we don't have any examples here, but you will see cases where something has reached high load, and the warehouse is really saturated. And assuming that's powering a valuable application, assuming the data is good, all of these things, that there's a strong case, empirical case based on the data we have to consider really up-leveling that and resizing it and getting some benefit from that. So this is just a tool that provides, it takes us beyond, in some ways like a finger in the wind or a little bit of guesswork in terms of understanding, should a warehouse be larger or should it be smaller? Okay, last bit I'll call out here is around tables. So tables, what we're really flagging here are what are people accessing? So are these tables being used? We're giving you some stats around what these end up costing, or sorry, what like how effective they actually are across this. And then the other aspect that's fairly unique here is really looking at the quality of the tables themselves. So on all these dimensions, I mean, let me go back even to the cost side. On all of these dimensions, you'll notice this view is always available, right? So this view to understand, great, we're querying this table, we're running this stuff, it cost us this much, here's what it is. We could have made it X% more efficient, but we're also going to say, hey, is this data even any good? So we're going to use this example around, stations and weather and bike sharing in Chicago here, just as an example. But we're basically going to say, hey, this data, what this is flagging is like this data is not necessarily good. So there's enough data, this is sort of volume, reconciliation, timeliness. This is data drift. This is data quality. What we're seeing is this data isn't necessarily very good. And we can do this for any of the tables that we have. And going back to one of the principles we shared earlier, Acceldata makes it very easy to actually apply this, and cost effective as well to apply this at a pretty large scale, both in terms of number of tables, number of things that you check, and volume of data itself. And so with that, why don't we actually cross over now and say, okay, let's say we've done what we can, pick up on kind of are these queries running well? Now let's get into, is this data even any good? Okay, so I'll just cross over. And what this is now showing is basically, one of the tables underneath this. So this actually happens to be in a Snowflake warehouse, but it could equally be a file or things like that, although you wouldn't see it on the other side if it was a file. So what we're showing here is basically, a couple of the ways that this can get broken down and how we profiled it. So just give a little bit of a sense of what we mean by some of these terms. They're sometimes used differently. Data quality is really, these are these deterministic checks that we look at, right? Like, are there nulls? Are things within the range that they should be? Are the values that we expect showing up, or are we seeing erroneous values that don't make any sense? Reconciliation can be, are we seeing exactly the same rows, or are we seeing the right number of rows? We also look at, data drift, schema drift, and sort of these sort of checks to understand, this is the standard type of thing, but something where you're able to understand, are there any statistical differences between the data we've seen now and the data we've seen later? Sometimes that's something that's relevant for a machine learning model where that's sensitive to the distributions of data being fed into it and will give bad predictions if it hasn't been trained in that area. Sometimes it's actually just a great way to catch data quality errors, right? If you see that the number of distinct values for something, the cardinality of a string field has blown up immensely, that's probably not a genuine shift in the world. That's probably a corruption in your data, and this isolates that for you very quickly. Great. So with this, let me just highlight a couple of these. Like we just applied these. There's a lot of sophistication around how these policies get managed, how they can get authored. I don't know if I'll try to show a little of that in here. But let me just show one element of this that's a little bit cool, especially as you get into quite complex scenarios. So what we're going to do here is, this was kind of basic, right? Like, we're looking at these attributes. We're looking at, are they kind of covering their dimensions? What we can also do is actually split this up by segment and by complex segment at that. So what we're going to do here is basically split by a couple things: the station status and the station type. Apply these to your situation. It could really be anything across here. And what we're going to do is take every rule that we did, every check that we did, and basically put this into, break this down by segment and flag on, okay, this was high quality, this is not. So where this ends up being extremely useful is when you have something like devices, or you have something like data providers where you're aggregating things from. Very easily, you now become able to say, oh, great, well, the aggregate value, this was 90%, quality. Okay, that's okay. But this provider is responsible for all of that, right? All of their data was terrible. And I can tell them, and I can tell anyone else who needs to know exactly where it failed, which rows actually even failed, if we go through this, which rows were good, what the traits of that are. So there's a lot of diagnostics beneath this where you're able to really spotlight instantly what these are. So this is a simple example, but I think this is one of the more powerful features where you can start to segment, intercept this as well. So, right, so you can pick multiple dimensions that you want to segment on. There's a lot that can happen here, and it provides a great way to really isolate where the problems are and where you need to go to fix them. I think the other piece that I'll highlight here, we talked a little bit about drift. I think there's a lot we can author. What I maybe want to show here a little bit is I just want to give a little bit of a highlight of the more complex end of the spectrum. So we talked about a lot of the simple ones. They'll be familiar to people. what I want to talk about a little bit more is basically something around here. So I'm going to take one of these kind of templates and just give you a little bit of sense of some of the things that you can do, in this platform. So I don't know if I want to edit or view this. So let's edit it. So for this, basically in Python, Java, JavaScript, Scala, you're going to be able to really write your own expression on this, validate it, and then save it back and publish it back basically to your organization. And so in this case, we're basically hashing two strings. We're going to compare if they're different or not. This is letting us, and in many cases, you'll see teams, as I said earlier, that have literally hundreds of these. And they know what good data looks like for them. They don't want someone to approximate it for them. They want to express that exactly and directly. And so this is something that allows you to do that and basically allows you to express and share that and make that easy to author. By the way, this also executes. I think one of the great things about this is this also executes in pretty much the same way, right? So, so all that segmentation that I showed, all that analysis, all the Spark layer, that's where this is being executed. So you kind of get to layer on your own checks that you might have been running for years at this point with some of the more novel insights around segmentation and lineage and then things like that. So I think that's a little, there's a lot that we can go through on this. I think what I want to maybe, cover on this as well is basically zoom back out, right? So what we're looking at, take another look here at what we're looking at. So this is the table, this is in the prod table, station status. So the thing about this is this table didn't, the data didn't fall out of the air here, right? This is looking at, if we look at the profile, this is looking at, quite a bit of information. Some of it's about weather, some of it's about bikes, things like that. So what we're going to do actually is zoom back out to the pipeline itself. So this node that we were just looking at was this. And that's actually downstream of many other transformations that might be from other tools, other platforms. And so, our premise, and this goes back to our sort of shift left tenet around data reliability, we want to shift actually our analysis back over to the left here and say, let's go all the way back. Let's instrument this pipeline. So this is actually an Airflow pipeline running in Composer. You can see we're running it every 3 hours or so and have been for quite some time. And 380 executions now. So what this is doing now is basically at every step along the way here, these also have their own data quality policies in here in many cases, right? And so what we can do is basically at any moment along this, we can eject, we can say stop. Now, we don't do that automatically. That's something that we provide guides to. There's ways, there's ways to do it very easily. We think pipelines don't necessarily need more help breaking than they already have. So we make it optional. But what you can do is basically define these policies centrally. So you can import them, shift them between assets. But it's key. One of the key point I'm trying to convey is you define the policies centrally, so that your data engineers out actually authoring these policies don't need to do that. They don't need to maintain that in code every time, and you're not, on the other hand, responsible for that, or you're not dependent on them to do it right every time. Instead, you define those quality policies centrally. Now, the person authoring the pipeline now has the tools to basically break the pipeline if they want to, eject if we're putting data through that's not any good. And Acceldata will actually also, can help quarantine those rows. It can help only route the good ones through. There's other extensions on top of this. But by shifting this all the way over here, we're basically able to kill this pipeline. So instead of all these runs, if we go back to some of the other ones, we can see, how long they took. We can break down essentially, how long it took. We can find which nodes basically processed in this on time, which passed, which failed, which were slowest, things like that. There's a lot of analysis that comes on top of this. And this is a pretty active area of work for us as well. So you'll see quite a bit more to come as well. But this essentially, gives you this whole pipeline view, reliability, even on files, even outside of warehouses. And by stopping things up here, you really get a number of benefits. All right, so there's two other bits I want to sort of highlight before we sort of pause for questions and then wrap up. So the first is, that we really view this as an operational platform at one level. So one half of it is really operational, And just as an indication of that, I wanted to give you a little bit of a view into kind of our incidents and overview command center, right? So what we're trying to do is give you this view across platforms. We're looking actually across Redshift and other platforms as well, but across Databricks, Snowflake, we're flagging when these are being opened, when they're being cleared. And so you, both as sort of an individual data engineer responsible for a given set of pipelines, and at different levels in an organization where you might be looking at your entire portfolio of hundreds, tens of thousands of pipelines and data assets, you're able to get a sense basically of how you're faring across the board here and what this looks like. So we really think, part of our vision and our premise as a company is, data is an essential asset. It's a mission critical asset for more and more organizations. And so the operational insights and the operational rigor that really has been established around software applications over the last 10, 20 years, that's coming to data as well. And we're very much a fan of bringing that forward. The last bit I'll highlight here, and I just want to wrap up here and then pause for questions, is really the other macro level view of where this is. So some of the strategic analysis of how are we faring basically on our data coverage as we go. So what we're looking at here is basically a breakdown of all the data assets we've analyzed, how fresh that analysis is, how fully those are covered, right? So looking at basically, does this data set have all the tests that it should have? Is it fully covered for data reliability? We know if data is late, we know if data is missing, we know if the data is erroneous, it's passing all of our custom checks, on this axis, versus how much is it being used? So if you've got assets down here that essentially are not being queried or not being used by anyone, these are ones that you might consider pruning if they're basically generating cost and no value. The real hotspot, unfortunately, in this case, we don't have anything here. The real hotspot is here, right? So things that are being used a lot, if you imagine thousands and thousands of assets, there's going to be some that are used quite a lot and that are also low reliability, whether that means they're not even being tested for reliability or it means they are being tested and they're consistently failing. This is where those get flagged, and this really gives you a great starting point to say, more from a data reliability focus, where can I invest my time and my resources in order to really, uplift my organization to where we really want it to be. So with that, that's kind of a quick tour through the key highlights of the platform. It's a very rich platform. There's a lot of depth in here, and so happy to take questions, and then would really encourage people as well to try to get hands-on, whether that's at a workshop or actually just signing up for a trial.
Great, thanks so much, Tristan. We do have a few questions, so I'll read them out loud so that everyone on the call can benefit from the answers. So one of the questions is, what is the implementation of this like, right? I've already invested in Snowflake and Databricks, and so what would it take to implement Acceldata to support both of those applications that you've demoed?
Yes, it's quite simple, actually. I mean, this ends up being like a 15-minute experience for most customers, but basically we would go in and basically add a data source, pick what we want to do, and basically put in the credentials. So if we wanted to do, let's say, Snowflake, we're going to come in, turn on really the types of analysis we want. We can install a data plane really on Azure, AWS, or GCP. That's what's going to go in and analyze your data for reliability and emit the key metrics back to our hub. And basically, it's as simple as that. So we put a lot of work into really automating this. Should not be hard to get the stuff set up. And so we think, pretty quickly, people are going to be gathering insights into, where their data is good, where they're spending resources that maybe they should or shouldn't, and yeah. So I think it's not even a full day process to kind of get that information. It's within an hour we'll see something great.
Great. Next question is, so can you give us a just high-level comparison of the cost insights that Acceldata is providing compared to what Snowflake is providing? We are part of both of the Snowflake and Databricks partner programs, so we do have strong official relations with them, with both those companies. But yeah, Tristan, if you could give a sense of kind of what we're adding over what those applications are offering in that particular area, that'd be great.
Yeah, for sure. And so I think the first thing is that, as you mentioned, I think this is something Snowflake is quite thoughtful about in terms of consistently trying to drive value for their customers. We're partners with them. They also partner with other people that look at basically offering us. because I think they believe in the strength of the platform that they offer, as we all do as well, and trust that if people see what they're spending on it and the value that they're getting from it, they'll see that it's a great deal and want to use more of it. So I think at a macro level, I think that's one aspect of it. I think you can get into some detailed pieces as well here. So let me just go over to the compute side and basically show a couple of this. So I think the first part of the question to answer is also around like, what do we mean by insights as well? So I think a lot of this data pretty much is available in Snowflake if you go through to the right metadata tables and grab it and pull it and look and analyze it and slice it and dice it. I think what's not necessarily there, and I think it's something that is coming as well, is around operational insights and alerting. So having a full-fledged alerting framework configured out of the box or tailored out of the box that's going to flag these and kind of identify resolutions as well, I think is something that's a little different. It's not a different information thing. It's a different delivery of that information in a way that allows faster response. So I think that's one aspect that this sort of platform offers. I think there's another aspect of the delivery of information that maybe is not obvious until you try it. And this is one reason I'd encourage people to try the products and try it around, is actually like the speed and analytics on this stuff. So one of the choices, not to get it too much into architecture, but like we've actually made a different architectural choice on this than some have, which is basically to index a lot of that information for rapid querying. So as I go through here, and I'm looking at, why don't we jack this up to 3 months? Looking at significant amount of information. So I'm going to run this. We can slice and dice this. We can go across these tables. I can filter into warehouses. This is all quite fast, and this is all using 0 Snowflake credits. So this querying is all done on our indexed, basically analytical database that we've set up here that is separate from Snowflake. And so what that means is you're able to get a lot deeper analysis. All the forecasting we do also runs in this, doesn't run in Snowflake. So basically there's a little bit of a trade-off of like, I can get this information, I can interact, I can find the root cause of the issue faster because I'm able to have like a truly interactive experience without, a concern about, by analyzing Snowflake, am I also increasing my Snowflake costs and this sort of dilemma. I guess the third aspect I would call out that I do think is quite essential and would encourage people to try with their data is the data quality insight. So Snowflake, I think, has a lot of like great partnerships and things like that, including with us. But what they don't have in sort of the UIs there is basically context on the data quality itself. So there's really not an ability to do. You can eyeball it, right? Actually, if you look at given result sets, you can kind of look at it. But to genuinely be able to look in and say, okay, great, I'm spending time on this. By the way, what is this query? What is this table? What are we doing with it? Is the data good? Where did this data come from? Like that part is not present, in Snowflake's experience and isn't really part of the goals there, I think. And it very much is a part of what we offer with our perspective on data observability. So I don't know, that's, I guess a few dimensions on where I think there's a few differences. Obviously the other macro difference I'll just call out is like zooming back out to organizations that have more than Snowflake, that have, also Databricks, also many other cloud data platforms, also some of the cloud, service providers own native systems. Our ability to basically give you perspective on currently, Snowflake and Databricks. In the future, that expands quite significantly to many other platforms as well. I think that also becomes a key trait in accomplishing these goals around basically budgeting and forecasting. And, should I run something on Snowflake or should I run on Databricks? Databricks says I should run on Databricks. Snowflake says I should run on Snowflake. GCP says whichever vendor says I should wear it there. Like having some facts around that and kind of a neutral place to kind of look at these side by side, I think is a useful trait as well.
Great. And I think you actually preempted a little bit the next question, which is, you talked about, obviously we're showcasing Snowflake and Databricks here, but what other kind of technologies do we support? You touched on that a little bit, but maybe you can go into that a little bit more in depth.
Yeah, sure. So, so I mean, this is a key thing, right? Because I think people see this and it's like, there's a lot you can do with this. I think, we really look at it in a couple of directions. One is, breadth of clouds, and the other is breadth of capabilities. So when we look at, breadth of clouds, like we've started with the two basically more prominent, I would say, multi-cloud offerings. We've also put in work here so that this actually works with data on all sorts of clouds, right? This works on Snowflake, on GCP. The data reliability works on GCP. Data reliability works on Azure. Like this thing's, we try to keep this matrix simple so people aren't thinking, well, like what about this over here and that over there, right? The second piece is then now basically going around to a lot of these cloud providers and saying, okay, Redshift, well, we do data reliability on Redshift. We do data reliability on Athena. There's more on Azure. If we try to set those up, right? We'll have BigQuery, we'll have GCS coming, right? So I think what you're likely to see is a lot of coverage filling out on that direction. And then I think the other direction that you'll end up seeing, and this is something that where our customers have guided us as well, is really thinking about this pipeline view. So if you zoom these pipelines back out, a lot of the times there is a streaming platform like way up at the front of this, right? So if we go back to our diagram, our stylized diagram of the architecture and where Acceldata fits in, a lot of times those systems are streaming systems, whether it's Kafka, raw Kafka, a managed Kafka, one of the alternative streaming systems that's emerging, like stream data processing systems that's emerging right now. There's a lot up there and there's a lot of complexity in there. So I think, short term, you're likely to see a lot of the sort of cloud data platforms get fleshed out. Of course, there's always more work on Databricks and Snowflake. Those platforms are innovating so fast, and we very much try to keep up with that as well. But I think you'll start to see this expand into even more diverse sort of types of processing as we go on and on.
Great. All right. Well, I'm going to be cognizant of everyone's time. It's it's after 11. I think those are all the questions that we have. So definitely appreciate your time. As Tristan mentioned, we will be offering workshops. So we will be sending email out to let you guys know about a data observability workshop, either in your area live or online. So be on the lookout for that. And again, appreciate your time. I know that's super valuable. If you do have any questions, feel free to reach out to me, Loretta@acceldata.io. And have a great day. And again, thanks so much for giving us your time. Bye-bye.